Hello everyone. So this is the question that I picked for section 2.4 to go over with you. This particular question, we're going to be doing a lot more with this type of problem in section 2.5. So that's why I picked this one. It's because it's going to be coming up more later. I also picked this one because it uses a fraction and people totally panic and struggle with fractions. So I wanted you guys to see one with fractions. So it says solve the equation where it's set equal to 0. So solve the equation when it's set equal to 0 is the same thing as a different question saying find the zeros, or find the x-intercepts, or find the roots. Solutions, zeros, roots, x-intercepts are all talking about the same thing. It's the x values that make the function equal 0. They are all talking about the same thing. And what's nice is it says given that -7/2 is a 0. They've basically given us one of the answers. Like we know -7/2 is one of the answers. Now, we also know that because this is degree 3, that there should be 3 answers. So I know I'm not done because the degree basically is telling me how many answers there should be. So, because we were given -7/2 as an answer, I need to divide that factor out of the polynomial. And if I can take that part out of it, I'll be left with a smaller polynomial that will be easier for me to factor, right? I don't want to fuss with factoring this. I want to take out the 0 that I know is there, and then I can factor a smaller polynomial that's left over. So we're going to do synthetic division with the 0. I know these numbers are not the most fun, but it'll be okay. And because they told me that this is a 0, I should end up with 0 remainder. Okay, so that's how we're going to know if we do this right, because I'm supposed to end up with 0 remainder since they told me this is an answer. This is a 0. So you bring down the first number. Then I need to multiply -7/2 times 28. So let me pull up my calculator. Okay, 7/2 times 28. It's going to be -98. Right? Negative times a positive is a negative. So 88 minus 98 is -10. -7/2 times -10, I know it'll be positive. Okay, so 7/2 times 10 is 35. I probably could have figured that out. That's okay. -37 plus 35 is -2. And -7/2 times -2, that one I actually know is 7. Okay? -7 plus 7 is 0, which is what I should be getting because that's my remainder. So now my polynomial has dropped a degree. If it was x cubed, now it's x squared, and if it was x squared, now it's x. So I have reduced my polynomial from something with 4 terms that was cubic to only 3 terms, and it's a quadratic. The nice thing about quadratics is even if you hate factoring, you can use the quadratic formula. So that's kind of the whole goal, is to reduce the polynomial until you get to a quadratic, because we have more options with quadratics. So This one might factor, but just to review the quadratic formula, we're going to do it this way. So it's negative b plus or minus the square root of b squared minus 4ac all over 2a. You need to have that memorized. Have to. And so I'm getting A, B, and C from these numbers. And the fraction bar is under the whole thing. Oops. Sorry. Okay. So I always simplify what is under the square root first. So I simplify this stuff. Sorry, my goodness. So I'm going to do 4 times 28 times 2 for a second. That's 224. But I know this is a negative times a negative, so it's going to be a positive 224. So let me write this down. Okay, it's a square root. Negative 10 squared I knew was 100, so I didn't type that in. A negative times a negative is going to make this plus 224. Okay, so you see how I'm doing this in parts. You don't want to just go and slap all this stuff in there. It really works better. You're less likely to make mistakes if you just take it slow and do it bit by bit. So that's 10 plus or minus, here's the 56, so it's the square root of 324. So the first thing we're going to check and see is that a nice square root? Does that work out nicely? And it does. It's 18. So it's 10 plus or minus 18 over 56. This is where I actually separate it and I do each answer separately. So I'll do this whole fraction with a plus, and then I'll do the whole fraction with a minus. So 10 plus 18 is 28, divided by 56 is 1/2. Oops, x equals 1/2. And then I'll do it with a minus, so 10 minus 18, negative 8, divided by 56. Ooh, that's got to be a fraction, but I don't know off the top of my head which fraction that is. Let me switch to my better calculator. Hold on one second. I do have one. Hold on, let me find it. Sorry about that, guys. I had to pull up my better calculator. It was in my program somewhere. So what did we just do? We did 10 minus 18 divided by 56. So it's the same long decimal, but in the nice calculators, I can hit math, and there's a fraction option. So I hit enter, and I get negative 1/7. Okay, so that's my other answer, is negative 1/7. So what this tells me, because these ended up being rational answers, meaning I could write them as a fraction. There's no imaginary numbers, there's no square roots. That tells me I could have factored this. This would have worked with factoring. But the numbers got a little ugly and it was these fractions. So factoring, even when it works, isn't always going to be the easiest way. This was a little bit easier, I feel like, than factoring. So going back to where our answers go, I have the solution that they gave me. I have to list that solution. Then I'm going to list my other two solutions that I found, 1/2 and negative 1/7. So the -7/2 they told me, the 1/2 and the -1/7 were the zeros that we found. And hopefully that's right. Yes. Okay? So the idea is you start with a 0, you divide it out so that every time you divide out a 0, you're reducing your polynomial's degree by 1. So you're going to do that until you get to a quadratic, okay? And then once you're at a quadratic, you can either factor it or use the quadratic formula, whichever is your preference. Okay? All right. If you have any questions, post them in the forum. Otherwise, I will talk to you later.